Okay, I'm going to go over the 6-3 practice set, and it's going to be pretty rapid. So if you want to pause and make sure that you can check your answers, that would probably be a really smart idea. All right, I'm go ahead and get started. Number 1, side AB and BC are congruent. Then we have side BD is congruent to itself by the reflexive property. Then we have angle ABD congruent to angle CBD by the linear pair postulate, or because all right angles are congruent. So if you look at each figure, you have side angle side and side angle side. So by side angle side, triangle ABD is congruent to triangle CBD, and that is a reflection. Number 2, we know angle F is congruent to angle H. Angle GEH is congruent to angle EGF. These two here. Side EG is congruent to itself by the reflexive property. So if you look at each figure, you have angle, angle, side, angle, angle, side. So by angle, angle, side, triangle FEG is congruent to triangle HGE, and that is an example of a rotation. Number 3. This is not congruent because all we have are two pairs of sides. There's not enough to say congruent. Number 4. Angle OQP and RQP are congruent. Then we have the orange angles at P that are congruent. Then we have the shared side in the middle here. PQ is congruent to itself by the reflexive property. Don't forget to put a reason when you're marking it yourself. So now by angle, side, angle, we can say that triangle OPQ is congruent to triangle RPQ, and that's a reflection. Number 5. TX is the same length as XV. Then we have SX the same as UX. I added an X in the middle there. You might have a different letter, and that's fine. Just change all the X's to whatever your letter is. And then these two angles here are congruent by vertical angles theorem. So on each figure, you have side angle side, side angle side. So by side angle side, triangle SXT is congruent to UXV, and that is a reflection. Number 6, angle W is congruent to angle Z. Then side WX, same as ZX. Then we have these vertical angles right here that are congruent to each other by the vertical angles theorem. So in the picture we have angle, side angle. So triangle WXA is congruent to triangle ZXY, and that's a rotation. Number 7, we start out with BC is congruent to CD. Then we have angle D and B are congruent because all right angles are congruent. Then we have this side right here of congruent to itself by the reflexive property. If you just look at the A's and the S's, it spells the bad word, so you might have been tempted to dismiss it, but it is the exception. This is HL. You have a pair of congruent hypotenuses, a pair of congruent legs, and of course, these are right angles, or I wouldn't have used the word hypotenuse. All right, number 8. FG is congruent to JK. Then you have GH is the same as KI. Then we have FH the same as JI. So by side, 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 triangle FHG is congruent to triangle JIK. You have to reflect and rotate that, but don't worry about that. I told you you're only going to have to do singular transformation identification. You don't have to worry about these that are compositions. All right, number 9. Side LM and OM are congruent. Then we have the angles LMN and ONM that are congruent. The shared side is congruent to itself by the reflexive property. But these triangles are not congruent because even though the top triangle shows side angle side, the bottom triangle shows side side angle. The bottom triangle is not showing side angle side. And if you're a little bit confused about that, just try to transform that top triangle to land on the bottom triangle, and you'll see that you won't get the angles to land on top of each other because it kind of looks like you could just flip it over MN, but then the A's don't land on top of each other. So that is a non-congruent pair of triangles. 10 is also not congruent. Even though this triangle over here is showing side angle side, this one is not. It's showing side side angle. So that's not congruent for number 10. Number 11, angle V and X, those two angles are congruent. Then we have all right angles are congruent, so the angles at W are congruent. Then WY is congruent to itself by the reflexive property. So if we look at each triangle, we have angle, angle, side, angle, angle, side. So VWY is congruent to XWY, and that's a reflection. All right, number 12, we have AZ congruent to CZ. Those two sides are congruent. Next, we have AB congruent to CB. Those are marked congruent. Next on the list, we have a shared side. It's congruent to itself. ZB is congruent to itself, so that's the reflexive property. So if you look at each figure, side, 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 so by side, 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 triangle ABZ is congruent to triangle CBZ, and that's a reflection. Okay, the next video that you need to watch will go over the rest of the problems.